We're going to take a look now at what happens when we have more than one vertical transformation that we apply to the same parent function. In question 1a, I asked you to sketch f of x equals 1 over x, but rather than giving you the table of values that we've been using in the past, I just asked you to include a couple of crucial points. So you should be familiar with this reciprocal function and basically know that it's this graph that exists in quadrants 1 and 3, where you've got both the y-axis as a vertical asymptote and the x-axis as a horizontal asymptote. You should know that shape without needing to plot a whole bunch of points. I'm asking you to include two specific points. Those are basically just going to help me to keep track of exactly what happens with the transformations and make sure that I'm drawing things to approximately the right scale. So if I had the point 1, 1 here, then we approach the horizontal and the vertical asymptote, and -1, -1 would be here because that's the -1 is the reciprocal of -1. So those are my 2 points, and that's just a slight improvement on what I graphed freehand because I've got these points right here in exactly the right place. Now if I look at 1b, I'm asked to sketch g of x, which is 2 over x plus 3. So I can see I'm doing two things to this parent function. 2 over x, that's 2 times 1 over x. So I'm multiplying by 2, which I know accomplishes a vertical transformation. And I'm adding 3, which I know is a vertical shift up 3 units. And so I'm asking you to sketch this, and what I want you to do, and we'll do it together for this one, is we're going to keep track of what happens to these points. So we're going to plot 2 points that are basically where these points get transformed to by these transformations. Now, when I'm doing more than one thing vertically, the order makes a difference. Because let's just take a look. The y value here is 1. If I were to double 1, that would make it 2. And then if I added 3 to that, that's going to give me 5. If I added 3 first, 1 plus 3 would be 4, and if I doubled that, that would be 8. So I'm going to get different answers if I do things in a different order. That tells me there's got to be a correct order. What I'm going to do is I'm going to just list, I'm going to create a little table here, but not a table of values. I'm going to list what I would do in evaluating the function. If I took an x value, what would I do to that x? And then I'm going to list the corresponding transformation. And that's going to help me keep track of what order I'm going to do the transformations in. So if I were plugging in a number for x, let's just say I was going to plug in 5. Well, the first thing I'd have to do is take the reciprocal of 5. So that's going to be, that's the reciprocal. That's my parent function. So that's the very first thing I do. And then, after that, I would multiply by 2. And then I would add 3. That's just order of operations. We do multiplication before we add and subtract. And I know that multiplying by 2 is going to perform a vertical stretch. And I know that adding 3 is going to be a vertical shift 3 units up. Notice I know that these guys are going to be vertical because I'm doing these things here after I evaluate the parent function. So the parent function gives me the y values that we have in our original model, and then I do stuff, so that's changing the y values that will be associated with those same x values. So the points I plot as I track where these gets moved, the x values aren't going to change, but the y values will. Okay, so when I'm doing vertical transformations, I'm going to respect that order of operations. If I would multiply by 2 first, I'm going to stretch by a factor of 2 first. And if I would add 3 second, I'm going to shift things 3 up second. Okay. Now, in the directions, I asked you to graph this on a separate set of axes. Until this point, I've generally been graphing things on the same set of axes so that we could compare the graphs a little bit more easily. But I found that if you do too much work on the same pair of axes, it becomes a little bit difficult. The graph becomes pretty busy. And since I've got to grade your work, I'm going to be a little bit selfish here and say give it to me on a separate set of axes. It's going to be easier for me to grade. I'm going to just do this one step at a time. Now, it's possible to do both vertical transformations in one step, as long as you do them in the right order. I'm going to do it one at a time. So this was my parent graph. And just copy that here with this point 1, 1, and this point negative 1, negative 1. Okay. The first thing we're supposed to do is do a vertical stretch by a factor of 2. I'm going to keep track of where that's going to send things. So there, I'm doubling my y values. So this point, instead of being at 1, 1, that's now going to be at 1, 2. And this point, instead of being at negative 1, is going to be at negative 1, negative 2. So those sort of turning points, these points were the points that were closest to the origin there, those turning points get moved, they get shifted up or down so that they become twice as big as they were. Now, when I'm working with the reciprocal graph, it has asymptotes. And some of my transformations might change the asymptotes. So I want to take a look and see, are the asymptotes still in the same place? What I did is I doubled my y values. Now, if I'm on the x-axis, that was my horizontal asymptote, the equation for that is y equals 0. If I double that, it's still 0. So the x-axis is still a horizontal asymptote. Here, this is a vertical asymptote. Now, if I'm stretching it by a factor of 2, well, it was already infinitely tall, okay? So that's not going to change the location of this asymptote at all. So the asymptotes are actually still at the same place. So we're going to still have a horizontal asymptote on the x-axis and a vertical asymptote on the y-axis. All right, then what we were supposed to do was move things up 3. So let's keep track of our points. 1, 2, I'm just going to add 3 to that y value. So now that becomes 1, 2, 3, 4, 1, 5. And negative 1, negative 2, I'm going to add 3 to that y value. So that becomes negative 1, 1. Let's also track the asymptotes. We had a horizontal asymptote here. The equation for that was y equals 0. I got to move that up. That's going to become y equals 3 is my new horizontal asymptote. Now, the x and y axis were already drawn. We always draw those when we're graphing something. So I didn't have to do anything special to include them in my graph. If I've got a horizontal asymptote at height 3, I must draw it in as a dotted line. Asymptotes have to be drawn in. Now, if they're at the axes, they are drawn. If they're at any other location, they have to be drawn in, and they have to be drawn in as a dotted line. Anything that I draw as a solid line is considered to be part of my graph. This isn't actually part of the graph in the sense that these points on this horizontal line here are not points on the graph. Okay. This is just going to show me that the bottom piece won't go above this line and the top piece won't go below this line. So that asymptote does change. As you're doing the homework and checking the answers in the back of your book, unfortunately, the back of the book uses computer-generated graphs, and computers don't follow the same rules that humans do. They tend not to draw in the asymptotes. That is not acceptable on work that you're turning in. It's very unfortunate that the answers in the back of the book don't include them. Any answers that I generate, I will be sure to include the asymptotes, and I will expect that. So I will set that example in all of the problems that we work out, and I'm being very clear, I expect you to draw in the asymptotes in your work. Let's check the vertical asymptote. So that was this. Now if I move that up 3, it's the same vertical line. So the vertical asymptote is still just the y-axis. So then my graph is going to look something like this. So we're approaching the y-axis here, but we're approaching the line y equals 3 rather than approaching the x-axis. So this here would be my final graph. Now, as far as showing your work, I'm fine if you went from this graph in part A straight to this graph in part B. But I do need to see that you did two things, that you did the vertical stretch and that you did the vertical shift as well. So one way of doing that is to do those transformations one at a time, as I've just done. Another way of showing that is to write down, as we did at the beginning of this problem, that what you're going to do is you're going to first stretch vertically by a factor of 2 and then shift up 3. But I do need to see at least one of those things. Either actually do them one at a time or just write down the list of transformations you're going to do in the order that you're going to do them. All right, so that's question 1. This video has been going for a while, so what I'm going to do is just put the next 2 questions up on the board. If you've got the worksheet, so you've got them already, you're fine, you can skip to the next video, but do those problems first. So I'm going to put questions 2 and 3 up on the board here, do those problems, and then return to watch the next video. We'll check our answers there. So question 2, part A, says to sketch f of x equals x cubed, and I ask you to include the points whose x values are -1, 0, and 1. So include those 3 crucial points, but you don't need to do the full table of values that we've been doing previously. And then for part B, on a separate set of axes, I want you to sketch g of x, which is, whoops, I've got the wrong page here. Here we go. Sorry about that. G of x, which is -1/2 x cubed plus 4. And I want you to keep track of where the points that you plotted in part A get transformed to. And then for question 3, I actually give you a graph. So we've got the point -2, 1, -1. And we've got the point 2, 1. And we've got a curve that connects those points like so. And I tell you that's the graph of f of x. And what I ask you to do is sketch g of x, where g of x is -3 times f of x plus 1. So you're going to transform this graph for problem 3.